In this video, we will see the major differences between hydraulic and pneumatic cylinders, their functioning, and their applications in the industrial sector. The common basic component used in these machines that converts fluid pressure to linear actuated motion is the hydraulic cylinder. As diggers on construction sites, assembly lines, but also industrial package machines. Before starting, it is essential to specify that there are differences between single-acting cylinder and the double-acting one. The single-acting cylinder can be ruled in one direction only, and the fluid gas, which is spread by a pump or compressor, enters from one end only and pushes the stem out. To guarantee that it returns to its original position, the single-acting piston is rejected by a spring integrated into the system. The double-acting piston, differently from the single-acting one, can be moved directly by the operator in two directions by sliding it back and forth along its axis. Consequently, there is inclusive control of the mechanical organ. This system is generally the most used for movement of many types of equipment, thanks to the possibility of full control of the same without being subjected to weighting or action of the control spring. Piston assembly shown here is the functional model of a hydraulic cylinder. It consists of a cylindrical bore with an end cap. Its function is to hold the fluid pressure when oil is pumped into the cylinder. A cylinder head is attached to the other end of the barrel. A piston rod extends from inside the cylinder through the head. It transforms the force from the cylinder to the equipment on which the cylinder system is used. A piston is attached to the piston rod. It splits the cylinder bore into two compartments and reciprocates back and forth when the pressure is developed on both sides of the cylinder chamber. A set of circular sealing rings are used in the interface of metals. The seals used between the surface of the metals in relative motion are dynamic seals, and those acting between two surfaces at rest with respect to each other are static seals. A piston seal acts as a pressure barrier between two chambers separated by a piston. The seal is used to wipe dirt from the rod while entering through the head and prevent contamination of oil. A rod guide ring is used to absorb transverse forces acting on the system and prevents metal-to-metal contact of the rod and cylinder head. Now let's understand the operating principle of a hydraulic cylinder. The model shown here is a double-acting hydraulic cylinder. In other words, this means that the system can extend or retract by using hydraulic fluid in both conditions. The hydraulic cylinder functioning is based on the principle of Pascal, given by B. Pascal, a well-known French mathematician who wrote the law of fluid physics in 1653. This law establishes that when an increase in pressure occurs at the point of the confined fluid, this increase is also transmitted to each point of the fluid inside the container with the same intensity. As we can see from the picture, a passage is created in the cylinder to allow the liquid to enter the chamber, which we will name C-A. Since the chamber is airtight, the fluid will exert pressure on all sides. The piston is the only moving part inside the cylinder, so when the pressure rises inside the cylinder, the piston will begin to move. At the same time, it pushes the liquid into the chamber C-B, which, exiting the cylinder, will have lower pressure. Here we can observe the hydraulic cylinder functioning on this digger. The cylinder is attached to the pump through some cables, which contain the hydraulic fluid. A control valve manages the introduction of the liquid into the cylinder chambers. The operator adjusts the pressure exerted by the liquid so that the cylinder piston can perform its linear movement in both directions. The operator can precisely control the digger arm from its position by simply increasing or decreasing the pressure in the cylinder chambers. The pneumatic cylinder is not much different from a hydraulic cylinder. Differently from the hydraulic cylinder, the pneumatic one uses, indeed, a compressed gas instead of liquid. Pneumatic cylinders and actuators are an easy way to gain strength and generate accurate linear and/or rotary movement, and they can be used in harsh environments. even in extreme temperatures. Light and requiring little maintenance, they generally produce less force and a lower speed than hydraulic or electrical systems, but they remain an economically advantageous alternative. The key components of a pneumatic cylinder include end caps, a piston, a rod, a scraping seal, a guide, and sealing gaskets. Pneumatic systems use compressed air to create rotary or linear motion and power applications. The pneumatic cylinder will use compressed air to act on the piston inside the cylinder to create the required movement. For example, tightening or to move a load along a linear path. A double-acting pneumatic actuator or cylinder has two holes which allow pressure to be applied for movement of the piston in the opposite direction than the one created by the first outlet. Generally, larger is the cylinder hole and greater is the output in terms of strength. JAES, having been in industrial supplies business for over 10 years, has become the contact partner for some of the main companies belonging to the world of industrial mechanics and has offered a full range of hydraulic and pneumatic cylinders in its catalog. Pneumatic cylinders can be used in a wide range of applications and are particularly common in factory automation systems. This includes production, handling, and packaging of materials in which they are used to position or move parts or tools and carry out pick-and-place activities.